Race for self-driving cars is hitting a 10 billion mile data wall. Traditional fleets like Waymo generate 25 terabytes of sensor telemetry daily per vehicle, but because they're often confined to well-defined loops like Phoenix or SF, they suffer from 40% deadheading, which is empty miles that provide zero revenue and negligible new data value. This inefficiency keeps operational costs stuck above $2 per mile, a threshold that destroys return on invested capital and prevents mass adoption. Uber translates this chaos into AI training through Shadow Mode. They allow partners to run trained AI silently in the background of live human trips. While the human driver navigates, the AI takes in all camera and telemetry data to constantly predict its own path. This measures the vector delta, which is the precise difference between an AI's digital guess and the human's physical truth, converting 8 million drivers into a moving sensor grid. But the reality is more complex. It's not a cheat code because the AI is not feeling the physics of its own mistakes. The bottleneck is the latency of the feedback loop. When a human makes a mistake, they feel the physical consequence immediately, the jerk of a steering wheel or the shudder of the anti-lock brakes. Edge processing is utilizing NVIDIA Orin processors delivering 254 TOPS, trillions of operations per second of performance with 3 millisecond latency. Now as the hardware costs collapse, with solid-state LiDAR dropping from $75,000 to the $300 to $400 range, the market value is migrating from the hardware itself to the operational data pipe. Uber is positioning itself as the regulatory firewall for global players like Baidu, Pony AI, offering fleet management as a service to manage the physical maintenance, cleaning, and compliance that software-only companies cannot handle alone. The AI in Shadow Mode is just absorbing data vectors. It lacks embodied cognition. To bridge this, AI requires the Hjorth parameters, statistical descriptors of activity, mobility, and complexity. Combined with the Gaussian process regression to model uncertainty, the server brain can finally estimate center of mass shifts and material stiffness. Without this, the system is just mapping the environment, and mapping is only half of the equation. For investors, the endgame is the shift to network as a service. Removing the human driver eliminates roughly $1.50 in labor costs per mile, pushing prices towards the sub-dollar adoption threshold required to unlock a $1 trillion market. Uber's hybrid network stabilizes the return on invested capital by using mean shift clustering to group and train for the long tail of rare edge cases that currently prevent full autonomy.